In this video, you're going to learn how to calculate percent yield. I'm doing number 1 from your percent yield worksheet. Please follow along as I go through in this video. So, we're given this equation, and our first task is to balance the equation. Well, let's see what we have. We have copper, silver, nitrogen, and oxygen. On our reactant side, we have 1 copper, and on our product side, we have 1 copper. On our reactant side, we have 1 silver, and on our product side, we also have 1 silver. On our reactant side, we have 1 nitrogen, and on our product side, we have 2 nitrogens, and on our reactant side, we have 3 oxygens, and on our product side, we have 6 oxygens. So I'm going to start by balancing my nitrogens, so I need more on my reactant side, so I'm going to put a 2 here. Well, that changes my silver to 2, and it changes my nitrogen to 2, and it changes my oxygen to 6. So now my oxygens are balanced, my nitrogens are balanced, my coppers are balanced. I just need to balance my silver. So I need more silver on my product side, so I'll put a 2 here. That will make that 2, and everything is balanced. So this is our balanced equation. Now we need the type of reaction. Well, notice we have a single element here, and it switches places with the other cation, and then we're left with a single element on our product side that has been switched out. Okay, so this is a single displacement reaction. So our next task is to figure out our theoretical yield. The question asks, and I'm on C now, 5.5 grams of copper metal reacts with excess silver nitrate. What is the theoretical yield of silver metal? So let's break this down. Our given is 5.5 grams of copper metal. Well, which one of these is copper metal? That would be just the Cu. Okay, so we're looking at just Cu. This is our starting point. It reacts with excess silver nitrate. That means we're going to have extra silver nitrate, which means for this purpose, when we're looking at the theoretical yield, or the yield of our products, we have extra silver nitrate, so this does not affect our yield because it's in excess. We are just going to need to be concerned with the amount of copper metal that we have. And our goal is, what's the theoretical yield of silver metal? So silver metal is going to be our Ag, so that's what we're looking for. And theoretical yield is grams. So how many grams of silver metal do we produce from 5 grams of copper metal? So in this case, our substance A is our copper metal. That's what we're starting with, and we're given grams. So we're starting with the mass of our copper metal, and our substance B is our silver metal, and we're trying to figure out the theoretical yield. So we're trying to figure out the mass of our silver metal. So this is going to be 1, 2, 3 steps. Our first step, we're going to need to convert from grams of copper into moles of copper. So that's shown right here. This is our first step. In our second step, we're going to need to convert from the moles of copper into moles of silver. And again, that's right here. So that's when we use the coefficients from our balanced equation. And in the third step, we're going to need to convert from our moles of silver into grams of silver. That'll be our theoretical yield, and that's when we use our molar mass equal to 1 mole. So again, this is going to be a 3-step problem. So let's start with our given. Okay, we're starting with the 5.5 grams of copper, and we need to convert it into moles of copper first. That's our first step. So we'll have grams of copper at the bottom and moles of copper on top. Then we're going to convert from moles of copper into moles of silver. And finally, we will convert from moles of silver into grams of silver. Okay. So these are our 3 steps, 3 multiplication signs. So when we convert between grams and moles, we are using 1 mole is equal to the molar mass. So we'll have 1 mole of copper is equal to the molar mass of copper, which can be found on your periodic table. Then when we convert from moles of copper into moles of silver, so that's mole to mole, that's when we use our mole ratio, the coefficients from our balanced equation. So our moles of copper is going to be 1, and our moles of silver is going to be 2. For every 1 mole of copper, 2 moles of silver are produced. And finally, we're going to convert from moles of silver into grams of silver using the molar mass. So we have 1 mole of silver is equal to our molar mass of silver, 107.87. So now we plug this into our calculator. We are going to start by doing 5.5 times 1, which will give us 5.5, divided by 63.55, then times 2 divided by 1, which is the same thing, so you don't need to put the ones in your calculator, and then times 107.87, which equals 18.67, which I'm going to round to 2 digits because that's how many digits I start with, so I'm going to round it to 19. And then I know that my grams of copper cancels out with grams of copper, my moles of copper cancels out with moles of copper, my moles of silver cancels out with moles of silver, so my units are going to be grams of silver. So I have 19 grams of silver. The next question says 15 grams of silver was collected at the end of the reaction. So they're talking about a lab that was done and 15 grams of silver was collected. What is the percent yield of this reaction? If you look at the top of your worksheet, it has the formula for percent yield. In this case, the actual yield is the 15 grams of silver. So that's our actual yield. That was what was actually collected during the actual experiment that was done. Our theoretical yield is 19 grams of silver. Theoretically, 5.5 grams of copper can produce 19 grams of silver. So our percent yield is going to equal 15 grams divided by 19 grams times 100, which gives us 79%. So that is our percent yield, which means we produced 79% of the expected product. Go ahead and continue through 2, 3, and 4.